218 decibels. That's louder than a gunshot, louder than a rock concert, nearly as loud as a rocket launch. And it comes from a shrimp, 2 inches long, snapping its claw. One snap, one bubble, one shockwave that stuns fish, kills prey, and for a split second creates a temperature hotter than the surface of the sun. This is the pistol shrimp, and it turns sound into a weapon. Fishermen have heard them for centuries. If you've ever snorkeled over a coral reef and heard crackling, popping sounds like bacon frying underwater, that was pistol shrimp, thousands of them, snapping constantly. But no one understood how they made that sound or why it was so loud. Then, in 2000, a team of scientists used high-speed cameras, over 40,000 frames per second, and they saw something impossible. When the shrimp snaps its claws shut, it doesn't just make noise. It creates a cavitation bubble, a pocket of vapor that forms, expands, and collapses in less than a millisecond. And when that bubble collapses, the shockwave is so violent it stuns or kills anything nearby. But here's what made scientists lose their minds. The temperature inside that collapsing bubble spikes to over 4,700 degrees Celsius. That's hotter than lava, hotter than most star surfaces. For a fraction of a second, this tiny shrimp creates conditions found in the core of dying stars. And it does it every single time it snaps. Let me show you how this works. The pistol shrimp has one oversized claw, sometimes half the size of its entire body. This claw has 2 parts, a hammer and a socket. When the shrimp cocks the claw, it pulls the hammer back, loading tension like drawing a bow. Then it releases. The hammer slams into the socket at over 60 miles per hour. The force is so intense, it shoots a jet of water forward at over 100 feet per second. And here's where physics goes crazy. That water jet moves so fast, the water pressure behind it drops suddenly. Water can't flow in fast enough to fill the space. So a bubble forms, a cavitation bubble. This bubble is only there for 300 microseconds, a third of a millisecond. But when it collapses, everything happens at once. The shockwave hits 218 decibels. That's louder than a .357 Magnum gunshot, which is 165 decibels. Louder than a jet engine at takeoff, 140 decibels. If you were next to a pistol shrimp when it snapped, you'd feel it. Underwater, sound travels faster and hits harder. The temperature spike? Over 4,700 degrees Celsius. For context, the surface of the sun is 5,500 degrees Celsius. This shrimp gets close, in a bubble smaller than a pea, and sometimes, just sometimes, the collapse creates a flash of light, sonoluminescence, the same phenomenon the mantis shrimp creates, but the pistol shrimp does it with sound. The prey, usually a small fish or shrimp, doesn't see it coming. One snap, shockwave hits, fish is stunned or dead. Pistol shrimp drags it into its burrow and eats. Clean, efficient, devastating. And the pistol shrimp doesn't even touch its prey. It kills with a bubble. Here's the genius of this design. The pistol shrimp's claw isn't just strong, it's a precision instrument. The socket has a groove that fits perfectly into a groove on the hammer. When they slam together, they create a seal, and that seal is what generates the high-velocity water jet. No seal, no jet. No jet, no bubble. No bubble, no weapon. Evolution fine-tuned this claw over millions of years. Every millimeter matters. And the shrimp can snap hundreds of times a day without breaking its claw. The structure is reinforced, designed to absorb the shock of its own weapon. But here's what's wild. Pistol shrimp are loud enough to interfere with sonar. During World War II, submarines used pistol shrimp colonies as cover. The constant snapping created so much noise, enemy sonar couldn't detect them. Entire reefs full of snapping shrimp sounded like static, white noise, perfect camouflage. The U.S. Navy still studies pistol shrimp because if you can understand how they generate cavitation so efficiently, you might be able to design better underwater weapons or disrupt enemy sonar intentionally. This shrimp is a biological weapon, and navies want to copy it. But pistol shrimp aren't just killers. Many species live with a partner, a goby fish. Here's how it works. The pistol shrimp digs a burrow in the sand. It maintains it, clears debris, keeps it clean. But the shrimp has terrible eyesight, nearly blind. So the goby fish stands guard at the burrow entrance. It watches for predators. The shrimp keeps one antenna touching the goby at all times. If the goby sees danger and darts into the burrow, the shrimp feels it and follows. In return, the goby gets a safe home, protection, shelter. It's one of the ocean's perfect partnerships. The shrimp builds, the fish watches. Both survive. And if a predator gets too close, the shrimp snaps, the goby flees, the predator gets stunned. Teamwork. But don't let the partnership fool you. Pistol shrimp are territorial, aggressive. If another shrimp enters their burrow, they fight, snap battles. Loudest shrimp wins. And they don't just use the snap for hunting, they use it for communication, territory defense, mating displays. One snap can mean, "This is mine." Another, "Get out." Another, "I'm interested." It's a language made of explosions. So what can humans learn from a snapping shrimp? More than you'd think. Cavitation technology. Engineers want to replicate the pistol shrimp's efficiency. If we could generate cavitation bubbles on demand, we could clean surfaces without chemicals. Cavitation blasts away dirt, treat wastewater more effectively, developed non-contact underwater tools. The shrimp does it with a claw. We're trying to do it with machines. Medical applications. High-intensity focused ultrasound, or HIFU, uses sound waves to destroy tumors. It's non-invasive surgery. Understanding how pistol shrimp focus acoustic energy into tiny, devastating bursts could improve HIFU precision. Imagine destroying cancer cells the way a pistol shrimp stuns fish with sound. Plasma research. That temperature spike, 4,700 degrees Celsius, creates a state of matter called plasma, the fourth state after solid, liquid, and gas. Plasma physics is complicated, expensive to study, requires massive equipment. But pistol shrimp created in a bubble, underwater, for free. Scientists are studying how the shrimp achieves this so efficiently, because if we understood it, we might unlock new ways to generate energy or create controlled fusion reactions. A shrimp might help us solve the energy crisis. Sounds crazy, but that's what researchers are exploring. Right now, on a reef somewhere, a pistol shrimp just snapped its claw. A bubble formed, collapsed, released a shockwave louder than a gunshot. A fish nearby is stunned, maybe dead. The shrimp drags it home. No drama, no hesitation. Just physics, biology, survival. The pistol shrimp doesn't know it's extraordinary. It doesn't know scientists study it, that engineers want to copy it, that navies used it to hide submarines. It just snaps, hunts, lives. But here's what gets me. This shrimp, 2 inches long, nearly blind, living in a sand burrow, wields one of the most powerful weapons in nature. Not teeth, not venom, not size or strength. Sound. It turned a claw into a cannon, a bubble into a bomb, noise into a knockout punch. And it does it thousands of times every day without thinking. Evolution didn't give the pistol shrimp what it needed to survive. It gave it what it needed to dominate. And maybe that's the lesson. You don't need to be the biggest or the fastest or the smartest. You just need one thing, one ability, one edge. And if you perfect it, you become unstoppable. The pistol shrimp perfected the snap. What will you perfect? If a 2-inch shrimp weaponizing sound fascinates you, subscribe. We cover the most extreme abilities in nature, real science, real creatures, zero BS. New videos every week. Hit the bell, don't miss the next one. What animals should I cover next? Comment below.